Hello, everyone, and happy homecoming. This is your first homecoming week. We've talked about senior design and future projects. This Nitro was created by a senior design team. So not only do we have great engineering students, but they have a lot of school spirit as well. Okay, but back to some work-related things. Reminder that the withdrawal date is October 31st. And at this point in time, 2 weeks out, you need to be talking to your instructor if you are struggling pretty heavily in any of your courses. You need to talk to them and see if they think that based on your current situation or upcoming tests, whether or not you should withdraw from the class or not. Those of you that might be struggling in our course, you will be getting an email from me just for me to reach out. I want to know what's happening and if I can potentially help you, or if the academic success coaches can help you. But again, October 31st, yes, it's Halloween, but it is also the withdrawal date, so keep that in mind. With regard to this lecture course and the modules, I've been a bit behind, I apologize, but caught up as of today. So do me the favor and look at the assignment dates. Be sure and look at the assignment date. I know the syllabus says that it's due on this day, blah, blah, blah. No, always look at the assignment date, because that's what's connected to the web course, which is what's connected to your grades. So if you see that the assignment is not due for another week, well then it's not due for another week, okay? So just always look at the assignment date instead of the syllabus. I've been getting a couple emails about that. Regarding registration, a lot of you have come to me and kind of shown me your schedules, which is great. I'm not officially an advisor, but I do say I'm not officially an advisor, but I'll always offer any kind of help if I can, and guide you to an academic success coach as well. But the course, the follow-up course to 1006 is EGN1007. It's called Engineering Concepts and Methods. It is part of your engineering pending requirements. I need to let you know that the lecture portion will remain online, just like we've done this fall, and the lab will continue to be in person. The lab, however, will shift from 50 minutes in length to 75 minutes in length. And the reason being is that we're going to be covering a lot more material, and you'll also be working on your Great Naval Orange Race boat project, which is a semester-long project. And we just need more time with you in the lab, and you'll need more time working with your teams as well. So that course, again, the lab will not be 50 minutes, it'll be 75 minutes. Okay, so focusing on what's happening today. My department, the Civil, Environmental, and Construction Engineering Department, is being featured today. And, I can say in all honesty, because I've got data to prove it, that these majors in particular are what we kind of call AI protected, in that they're not as vulnerable to the onset of AI as some other careers might be. In fact, currently, according to Bureau of Labor and Statistics, civil engineering has a 1% nationwide unemployment level, and construction engineering has a 0.7% unemployment level. So obviously those two majors very employable, and so that's interesting information to know about those fields. Part of what you're going to do today is you're going to meet with a research team, Dr. Steven Duranzo, a colleague of mine. He and I worked in industry together, actually, and then ended up together here at the university. But Steve is an incredible researcher, and I really want you to pay attention to the students in that lab and what they're doing, because it's really an example of what you can accomplish if you get involved in undergraduate research here at UCF. So we're grateful to Dr. Duranzo and his team for providing lab video and content and introducing his students. But most importantly, we wanted you to just see these students and see what you can do, not just in environmental engineering, but the team and that collaborative effort that happens in mechanical, in industrial, it happens everywhere. So we really just want to highlight that undergraduate research experience. All right, so with that being said, happy homecoming, and I hope you enjoy learning more about civil, environmental, and construction engineering. Have a great weekend, everybody.
Welcome everybody to our presentation of the Department of Civil, Environmental, and Construction Engineering. So we're going to go through a presentation. We're going to show you all the basics of the department, all the way from the composition to what we do in our everyday life as civil engineers. So civil environmental and construction engineering uses math and sciences to put every single idea that we have in our brains into the physical reality. It's one of the oldest engineering professions, but we're still at the forefront of the technology and development. We use computers, parallel computing, big data to put all these ideas and all these designs together. We use robotics, laser sensors, and nanotechnology. Improving the quality of life is one of the biggest goals of our profession in terms of designing safe structures, infrastructure, and transportation for the safe and air for safe air and water as well. In the civil engineering department, we have a profession with significant responsibility, and all the mistakes might cause major implications, including life or death. So in the civil engineering department, we are 40 full-time faculties and lecturers. We have approximately 1,250 undergrads and 200 graduate students. We are very active in research. We bring approximately $6 million in research expenditures per year, and we are home of 3 undergraduate programs, 7 master's degrees, 2 doctoral degrees, and 3 certificates. In the civil engineering, construction, and environmental engineering departments, we have undergraduate programs, Bachelor of Science in Civil Engineering, Bachelor of Science in Environmental and in Construction, and we have some accelerated BS, MS, 5-year programs. We have graduate programs as well, masters and PhDs in civil and environmental engineering. In terms of the civil engineering, there is some subdisciplines that I want to navigate through. The first subdiscipline is the structural engineering component of our civil engineering profession, then geotechnical engineering, transportation engineering, water resources engineering. Structural engineers design, analyze, and plan buildings, power plants, bridges, dams, and other types of infrastructure. Structural engineers are typically employed by design firms and federal state agencies and need to be good at math and solid mechanics. There is all kinds of cool stuff within the civil engineering department um, in our CEC programs. In terms of example of structural engineering, there is numerous things that a structural engineer can design, all the way from bridges, all the way from any kind of infrastructure related to space or to anything related to um, um, bridges and buildings and power plants, even roller coasters in our Floridian landscapes as well. So in terms of testing and sensors and computing power, we also are very, very in the forefront. We need to design against all kinds of different earthquakes or all kinds of different geohazards within our profession. There is numerous computations that we can make so that everything that we design is safe and is technically sound. Geotechnical engineer, which is what I do, is my core of research. I am, by the way, Luis Arboleda. I am in geotechnical engineering. And we normally design, analyze, and test soils, rocks, and foundations for structures, slopes, and pavements. We are typically employed by design firms, by all kinds of contractors and state agencies. And you need to be good at math and solid and fluid mechanics in order to become a geotechnical engineer. There is different designs and examples of geotechnical engineers of the things that we do. We do all the way from deep foundations to the design of retaining structures, to the design of tunnels, to the design of anything that is related to the support of any type of infrastructure that you might think, all the way from bridges to pavements to buildings to nuclear power plants to industrial applications or in any type of warehouses. They need to be designed in the ground, and that's what we do in geotechnical engineering. All kinds of different problems arise in the geotechnical engineering profession, all the way from settlement of underground of any type of above ground structures. Stability is a big concern. Seepage, which is infiltration of water through the ground, is also a big concern, and we are making all the calculations in our profession to make sure everything that we design is safe from those viewpoints. Transportation engineering is another component of what we do. So transportation engineers typically plan, design, and operate transportation systems, including highways, railroads, airports, and mass transit systems. Transportation engineers are typically employed by design firms, municipal governments, and tech companies. They need to be good at statistics and data analytics. Different types of transportation engineers, or different examples, are related to port structures, any type of urban transit systems, bridges, airports, all these spaghetti complicated designs of infrastructure. Highways, for example, is also designed efficiently by transportation engineers. All these interchanges, for example, like the one that is shown in the pictures, is one of the Denver multi-level transportation mode. In terms of research and in terms of cutting edge technology, transportation engineers design interchanges such as the one that were shown in the previous page. And in terms of newer technologies, autonomous vehicles, smart systems, Internet of Things are very important components as well of what transportation engineers do. In terms of water resource engineers analyze and design water supply and drainage infrastructure. Interaction of water with land and infrastructure is also another big component of what they do. They are employed by design firms, regulatory agencies, for example, the Army Corps of Engineers, and they need to be good at math and at fluid mechanics as well. Some examples of what happens in the world of water resource engineers. They design, for example, everything related to the expansion of the Panama Canal to be able to accommodate all kinds of different modern ships, for example. There is numerous logs, numerous water irrigation problems too that they need to solve within our urban infrastructure. In terms of surge, floods, and ecology, given climate change is one of the big hazards that we currently have, there is a lot of storm surge problems related to hurricane environments as well. And everything that is related to storm surge and modeling in that direction is also conducted by people in water resources. So they use large computer models and high performance computers to be able to analyze all these interactions within the surge, flooding, and ecology type issues. In terms of what is critical for the major success of civil engineering profession within the civil engineering profession? There is a lot of early courses that you will have to take, all the way from calculus 2 and 3, differential equations, and in terms of statistics and mechanics as well, needs to happen within the early classes as a civil engineering major success. In terms of critical skills, you need to be good at physics, you need to be good at engineering mechanics as you pass through every single of these classes. You need to have an analytical brain and be also very tech savvy and very curious. It's very important curiosity within this profession. And some critical to do items is, for example, internships. Internships help quite a bit at the junior or at the senior level to be able to gain some experience. And within the department, we provide all these opportunities in all kinds of different activities or any type of different groups as you can join, or student organizations also help to be able to develop all your skills. In terms of environmental engineers are the ones that deal with the following four components. So in environmental engineering, there is four components. The first one is being air pollution control. The second would be solid and hazardous waste. The third is going to be the water treatment. And the very last one is the wastewater treatment control. So in the future, maybe we'll have to add back a soil and groundwater remediation. And also we might be thinking of adding another component of environmental health as is something that is current in our environment. In terms of air pollution control engineers, we design air pollution control systems, evaluate pollutant loadings, and enforce regulations to be able to have good air quality within our major environments, our major urban environments. These folks that work in air pollution and control, they are employed by consulting firms, by regulatory agencies, and by municipal governments. They need to be very good at math. They need to be very good at chemistry and thermodynamics. In terms of air pollution control example are, for example, those related to different operations of power plants, for example, in that case. And if you think a little bit beyond the cutting edge of these air pollution systems, forest fires and volcanoes, for example, are also natural sources of air pollution, while vehicle emissions like the ones that we see in this picture and all kinds of factories within our major populated cities, they're man-made sources of pollution, and those need to be controlled somehow within this profession as well. In terms of In terms of dispersion and health and carbon offsets, air pollution is a problem that is worldwide. There is a couple of examples of cities right there in some of those pictures. For example, Malaysia, Beijing, Los Angeles are cities that are impacted not only by the air that we breathe and the quality of the air of the air that all these citizens live, but also has destroying effects on buildings and great works of art, and that's a very, very major concern in this part of the civil engineering and environmental profession. So the other component is, for example, the solid and hazardous waste engineers. These are engineers that design and operate facilities for waste management, remediate contaminated cities, develop and enforce regulations, and they are employed by consulting firms, regulatory agencies, municipal governments, and need to be good at chemistry, for example. So one of the examples in the picture is one of those of hazardous waste incineration plants on the top right. And the design, for example, of landfills is an art as well that needs to be developed within these solid and hazardous waste engineers. So there is some examples in this view. I was mentioning the design of landfills is a major, major critical concern in our urban environments. We need to design landfills to be able to protect all this leachate and all the infrastructure for this leachate that is produced from the byproduct of landfills. Recycling facilities and all these are important infrastructure systems that need to be developed by these folks within the environmental engineering profession, so that we can safely build an environment that we can live in comfortably. In terms of recycling, sustainability, and waste of energy, and waste to energy, there is new and innovative uses for products that can be recycled, or at least better ways to use and safely integrate them into our landfills, as I was mentioning before. So biosolids is another big important thing of the research that we do within this component of environmental engineering. And biosolids can be a fuel source as well. And that is something that is also being developed within our department. Waste to energy and cogeneration plants are also important part of the designs that we conduct within this emphasis. The last one here is the water and wastewater engineers. Water and wastewater engineers design water and wastewater treatment facilities. They develop and enforce regulations for protecting water resources. They are employed by design and consulting firms, regulatory agencies, and municipalities. And these folks need to be very good at chemical and biological processes, as well as the very core of the other engineering classes that you will see as you become specialized within the water and wastewater engineering emphasis. So all kinds of different possibilities within these areas. We have experts in our department that are working currently with all kinds of water treatment plants, locally and statewide and nationwide, in all kinds of cutting edge research projects. Water and wastewater treatment are examples within these pictures that we see right there, and is at the forefront of what these folks have to deal with in the everyday life of a wastewater and a water resource engineer. Desalinization, reuse, and gray water, and how to treat these gray waters is a main concern within this profession as well. So desalinization is something that would be in the future very nice if we can start somehow getting some sort of source of water from oceans. If we can have this potentially conducted in a cost-effective and safe form. So desalination uses quite a bit of energy and hopefully produces some energy from this process as well, and is also part of the cutting edge research that our folks are doing within our department. What is critical for an environmental engineer to be successful, not only within the coursework, but also at the end of the coursework and when joining the labor force? Needs to have very critical early courses, for example, chemistry 1, chemistry 2, needs to be good at thermodynamics as well, and thermomechanics. So it needs to be good at the introductory levels in these early courses that you are going to be seeing on environmental engineering. And in terms of the critical skills, they need to be good at chemistry and processes engineering. Need to have an analytical brain. So what is interesting, or what can you do to improve your skills in that sense? would be, for example, again, securing an internship at the junior or at the senior level during the summertime, for example. Internships open up all kinds of different possibilities, gives you hands-on experience, and eventually, if you're very good at the work that you do, you might be able to secure a job forever. That's very helpful as a byproduct or as a final product of an internship. So you can join a student organization as well to be able to, to share everything that you have learned throughout the classwork with your classmates. Construction engineering is the very last component of our department. As I already mentioned, we're civil, environmental, and construction engineering. In terms of the construction engineering, we are a profession that basically manages all the technical and management skills to plan, construct, and deliver projects. We are employed by construction firms, and these folks need to be good at resource and project management. For example, estimating, scheduling, dealing with construction equipment and construction methods, all kinds of human resource management as well, and financial management is part of what they do in the construction engineering department. Different examples of construction engineering. Here's an example of a difficult construction project, a cantilever or overhanging bridge in a remote area. That sequence needs to be very carefully designed, and this is part of what a construction engineer needs to do. You need to use all kinds of cranes, all kinds of heavy lifting materials needs to happen throughout this construction of building it block by block, and the sequence of these cantilever bridges is also, as I already mentioned, is something that the construction engineer designs and puts in practice into the actual field conditions. Often the construction projects are in environmentally sensitive areas, like for example, in Hawaii is one of those very sensitive areas right now. There are numerous construction projects. Other cases involve major construction in the heart of, for example, all kinds of different busy urban environments, call it, or major cities, New York, or call it, Boston or San Francisco. There is all kinds of construction that happens, and all these systems need to be heavily monitored with lasers and heavy equipments and augmented reality type technology as well. So to finish this presentation, I just want to highlight that we are a profession again of quite a bit of responsibility. Our decisions impact how we use our urban infrastructure from the very beginning of our days to the very end of our days. We have to deal with civil engineering, so very early in the morning, we drive infrastructure, we use infrastructure, and we go back home and we use all kinds of infrastructure right before we go to bed. So we are a profession where everything that we learn is applicable to our everyday life. So in terms of our department, feel free to reach out. There is in the screen you can see the email of our department chair, Dr. Kevin Mackey, our undergraduate director and co-chair, Dr. Ding Bao Wang. His email is also right there. Mary Rush help us as an academic coordinator. And I wish you guys the best when you're about to decide what is going to be your major. And we're going to be very happy to see you within the Civil, Environmental, and Construction Engineering department. I'll see you. We driving. I'll see you.
Hello, my name is Dr. Steve Duranso, and I'm a professor of environmental engineering here at UCF. And what we're going to show you today is some of our work that we're doing for one project. We work in water quality engineering and mainly drinking water, public health, waterborne disease, these types of things is what we study. And so one of our experiments we've been doing is corrosion testing. So I think your professor had talked about Flint, Michigan, and the issues that were there because bad decisions, exposure to lead and copper at the tap, people's faucets, cause children to have lead in their body, and that's not a good thing. So we have regulations under the Safe Drinking Water Act that regulate exposure to contaminants. When you go drink out of a water faucet or a water fountain, your exposure to a potential contamination or something bad is involuntary. So there's a series of laws that protect public whenever you drink from a public water system, not just from your home or from your dorm room or for wherever. And for those of you that think bottled water is better, actually tap water is better than bottled water from a safety standpoint. So what we've done is that when we're doing corrosion studies, you can do full-scale corrosion studies, which we do. You can do complicated piping loop and rack studies. put a bunch of equipment on there, which is expensive. And then you can do what we call bench scale studies, and we've modified the way that we do these studies to make it more accurate. So we're working with the city of Sarasota on this particular project, and they are getting ready to build a huge new water treatment plant and expand their system. And so they've asked us to help them project what the corrosion will be for these new technologies that they're using to better improve their water system. And so what we've done is we've taken a separatory funnel. Some of you might see these in some of your labs that you take here, or in your high school labs if you took these types of labs. We modified it. So we modified it to kind of like simulate water flowing through these funnels. The reason we did this is because if you were to go in the industry, you'd use these little jars. A lot of people use these little jars and they put the piece of metal in the jar. We found that wasn't very accurate. So we've improved the method. And so what happens is that we put a piece of metal that would be in your faucet or your copper pipe or in the brass fixtures to simulate what happens in your household. And then we test different chemical treatments to see which one works the best. So today with me I have one of my graduate students. This is Ben Farquhar, and he's going to talk to you a little more what he's going to do about how we're testing this particular test. And we do these tests frequently, 2-3 times a week. We're in here changing the water supply out. We go to Sarasota, get the water, bring it back here and do the tests. And then Ava will be talking about some testing. She's an undergraduate scholar and she'll be testing some of talking about what she's doing. Thank you.
My name's Benjamin Farquhar. I'm an environmental engineering graduate student. I'm a master's student. And part of my thesis project has been working on the Sarasota corrosion study. And so since May 5th was our first site visit, and since then, every week we've been collecting bulk water and bringing it back to our UCF labs. And we've been flowing it through these funnels with metal coupons inside. And so twice a week, I empty the funnels, collect them into these brown sampling bottles so that we're able to measure how much metal was released per sampling event, and then as well as measuring different water quality parameters with the assistance of the undergraduates. And so yeah, this is the last flow-through event, and yeah, these are the jars I'm collecting. And for this one, I'm specifically interested in measuring the specific volume of the funnels. It shouldn't fluctuate too much from funnel to funnel, but this is so that at the end, when I'm looking at the data, if there's any weird fluctuations, maybe I'd be able to gather a relationship from volume that I wasn't expecting. Yeah. And then on the other side, I can empty those out, I feel like, while talking. Maybe that'll be cool so you can get the visual of the funnel. Yeah, so this is the last week of our collection. This is actually our last samples being collected. But if this were a normal week of flow through, I would have been in Sarasota yesterday, and today I'd have the bulk water. And I actually collect 3 different sources of bulk water and blend them together at like a prescripted blend ratio, like 60% one water, 12% another water. And then once we have that, I inject different chemicals, sodium hypochlorite in order to disinfect, and then caustic to bring the pH up. And then our corrosion inhibitors, which are the things that we're actually testing for, one corrosion inhibitor on this side, another corrosion inhibitor on this side, and we're comparing the two so that we're able to give the city of Sarasota kind of a preview of which corrosion inhibitor might be better for their specific public water supply. Bonds are, I think, like 99% or above iron, and typically that's not what you're going to see. You see a lot of PVC pipe nowadays, and so, you know, it won't be as corrosive as this. And so with these drained, you can see a visible difference just in the empty funnels. The discoloration from the iron is pretty heavy, as well as the coupons themselves. Perfect. Yeah, so these are some of the funnels that I'm going to be emptying out so that we can perform water quality analysis on them, and then later observe the metals in them. And so I open the modified separatory funnel, and then it'll slowly drain into the bottle. And as you can see, these specific coupons corrode a lot heavier than the others, so you can see all of the suspended iron and the water that slowly leaks down. And with our instruments, we can't analyze it with so much suspended material. So I do acid digestion in order to bring the pH down and then get a total amount of iron that we can then measure in our instruments so that this doesn't clog up our machine. Yeah, and these iron funnels would indicate kind of a worst case corrosion rate. Obviously all that suspended metal coming down, you don't want that at your tap. Whereas this leaded brass, these coupons would more or less represent more of what you'd have at your tap. As you can see, the water and the funnels themselves are not nearly as visually discolored. And with these coupons, this specific one has been kept throughout the entire duration of the study, about 20 to 24 weeks. And this one was placed in halfway through the study, so that's about 12 weeks. And you can see the visual differences between the two, where you have a different color gradient for this one. And the newer one doesn't feature nearly the same color gradient.
Hi, my name is Ava McClyman. This is my 5th and final year as an environmental engineering student here at UCF. I've been working in the water quality engineering lab for a little over a year now. And
I'm Olivia Tedeschi. I'm a civil engineering major. This is my final year as well, and I just got here, so only a couple months ago. So we help Ben out testing some of his water samples, and I usually operate the probes, and they test for oxidation reduction potential, pH, conductivity, and temperature.
And then we also use the colorimeters. This is for the ortho residual as well as the residual chlorine to see how well the different corrosion inhibitors, as the water moves through the system, how well it reduces them.
So hopefully you've learned a little bit about one type of project that we do and how undergraduates help us. Our undergraduate students are very important to a lot of professors that do research. And it's because this is a civil engineering and an environmental engineering student. So in our department we have civil, environmental, and construction engineering. And so when you start going through your classes and start trying to find out what you want to do, you should explore, like in this class, all the different engineering fields. But in our field, particularly environmental engineering field, it's where humans, the environment, and all the things that we do come together. Buildings, roads, highways, you know, how you water, you turn on your tap water, you put out your garbage, where's the garbage go? You breathe clean air, or you at least hope to. And so that's what civil environmental engineering do. We are we work on this, everything that you touch on every day, how you get to work, how you get to school, how you, what you eat, what you drink, all those things are involved, and we provide that to society to protect them from harm from the environment, and also protect the environment while we're building our wastewater plants and building our water treatment plants. We are also protecting the environment with our discharges. You just can't discharge anything you want into the environment. So that's what you learn in our program, is how society works and interfaces with the environment and all the tools and all the things that we live in. And so that's the things that we study in our program.
Hello everyone, my name is Edward Colazo Borges. I'm the president of the American Society of Civil Engineers, University of Central Florida Student Chapter, or ASE.
Hello, my name is Eva Ilieva and I serve as the internal vice president for the UCF ASE Student Chapter.
Hi, my name is Paulina Tavral and I'm the ASCE UCF Marketing Chair.
And my name is Dean Schroeder and I'm the ASE UCF Workshop Manager.
ASE is a professional engineering organization where anyone interested in civil, environmental, and construction engineering can join. We have general body meetings where we hear from various civil, environmental, and construction companies. We also have community service events, professional development events, and socials.
One of the most important parts of our organization is the annual Southeast Student Symposium, where we compete in 16 different competitions across all the civil engineering disciplines.
This year, our symposium will be in Boca Raton, Florida, where you'll have the opportunity to get hands-on experience and compete against other schools.
This is the workshop where you can expect to work on fabrication for various competitions that Paulina mentioned. I personally really enjoy the workshop because there's a lot of tools and equipment that ASE members can access. In our workshop, we store a lot of our material, including material for a concrete canoe, as well as in our Steelbridge box where we put our Steelbridge members. If you want to get hands-on experience within our workshop, the best way is to join our ACE competitions.
One of our main competitions is Sustainable Solutions, where you work as part of a team to implement sustainable and environmentally friendly designs on a land development site. Here, I got to implement engineering concepts learned in class and use it on real-world projects.
This year, I serve as the visual design and report captain for the Timber Strong competition, where we design and build a small-scale two-story wooden structure.
And my personal favorite, Concrete Canoe, where we design, build, and race a 19-foot-long concrete canoe.
There are also smaller regional competitions you can join, such as traffic control and muddy waters.
These smaller regional competitions that Dean mentioned, along with several others, are a great way for new members, especially underclassmen, to get involved in our organization and have the opportunity to compete at our Southeast Student Symposium Conference this coming year. By joining one of our regional competitions, you'll also have a chance to learn more about how our chapter here at UCF operates and get to know several of our other members and officers.
Our Southeast Student Symposium is my favorite part about ASC, where I had the opportunity to network with professionals in the industry and make memories with my best friends.
My favorite part about AAC is the Steelbridge competition because I enjoyed being on build team and competing on competition day.
My favorite part about AAC is the professional development events. From LinkedIn workshops to resume critiques, I was able to secure my very first internship like many of our other members.
What I love most about ASCE is all of our social events, such as tailgates or a back-to-school barbecue, as it offers the perfect environment to get to know your peers in an out-of-classroom setting and make some great friendships. To get involved in our organization and these events, be sure to follow us on Instagram and join our Discord.
To become an official AAC member, be sure to join on NetConnect and pay your dues.
Thank y'all for watching. Hope to see you at all of our GBMs this fall. Go Knights!
Charge on!
Hello, I'm the secretary for the Society of Environmental Engineers, and I'm just going to be telling you guys a little bit about our club. So here are our officers. We have our president, vice president. I'm the secretary. We also have our treasurer, our media manager, and our conference chair. And for our upcoming events, we have our second GBM happening on October 9th with Kimley Horn. Then the 28th, we're going to have our third GBM, and we're going to be having a research night where professors are going to come in and tell us a little bit about their research. And then early November, with the date is still to be announced, but we're going to have a beach cleanup. And mid-November, we're going to have our FSA WWA Model Water Competition. Then mid-November again, we're also going to have a tailgate for one of the football games. And November 13th, we're going to be having our fourth GBM with CDM Smith.
We will be funding the club's attendance to the FWRC Student Design Competition, which will take place from April 26 to April 29 of next year. We will be taking 2 teams, wastewater and environmental design teams, and students will be able to attend this conference for free. So if you guys are interested, definitely check that out. Dues are $10 per semester or $20 the full year. This will get paid members access to exclusive events such as resume or professional development workshops. They will also help host events, provide food at GVM such as Chick-fil-A or Pops-Ups, and if you pay dues, you will get access to t-shirts. Alrighty, so this is the t-shirt design that we will be offering this year. So if you're interested in getting a t-shirt, be sure to pay dues. It doesn't matter what type of engineering major you are, if you're still deciding your engineering path, or you are simply interested in learning more about the environmental engineering field from professionals in consulting and research, then the Society of Environmental Engineers is for you. We will be hosting general body meetings, plant tours, social and networking events throughout the semester. So if you're interested in learning more about the club, be sure to scan the QR code and check out our link tree.
Hi everyone, welcome to Go for Launch the GTAs. Today you heard from CECE all about what they do and their department, and you got to tour one of their labs.
Yes, you did. So you got to see a couple of one of their labs. You got to talk to one of the department heads as well and learn a little bit about who they are, what they do. And also, our favorite announcement every single week, you have Excel due on Sunday at 11:59, so make sure you're keeping up with those if you haven't already.
It's our second to last time making this announcement, so
Almost done.
almost there. What other assignments? Oh, in 2 weeks, you will have your launcher due in lab, so make sure you start working on that now, so that way you can get that approved by your TA and get that built out. Your peer evaluations will also be in 2 weeks, so just get prepared for those.
Yep. And for those duck launchers, this first set of launchers that you guys are going to be making are your prototypes. So this does not have to be set in stone. If you change your design afterwards, that is completely fine. But for right now, we just want to get something moving so you guys have something to test with in a couple of weeks as we keep moving through the duck launcher in your labs.
Yep. So you might be wondering, why are we here at the reflecting pond? And well, today is Spirit Splash. It's one of UCF's biggest traditions where our homecoming court tosses ducks out to the students. And we have 2 of our homecoming court members with us here. Come on out. You're fine.
The water's fine.
So we've been talking about this in lab. We've had Belle and Caitlin for homecoming court this past week. They've done a lot of cool things, and you'll see them today at Spirit Splash. So what do the students need to know about Spirit Splash?
Get there early. Get excited.
Get excited.
Be aggressive.
Yes.
Don't push people over, though. That's rude.
No, be kind.
Yeah.
Number 4, be kind.
We don't want anyone to get hurt. But we hope you enjoy all of the homecoming festivities. What other festivities are there for this weekend? Football game.
Saturday, noon.
What's before the football game, Ella?
Tonight is Ignite the Night. Yeah, there'll be a fireworks show, food, games.
What time and where?
It'll be on Memory Mall.
And
It's a family event. Bring your friends, your parents, your siblings.
Absolutely.
It starts at 6:30 and fireworks are at 8.
Very nice.
All right. And with that, we hope you guys have a great weekend and happy homecoming.